This is page 6 of the Chapter 6 notes. We're going to be looking at the steps for naming binary ionic compounds from formulas, and we're going to be looking at also what we do with transition metals. So let's take a look at the steps that we're going to do first. First, we're going to break down the formula into element names. So break down formula. Into element names. So break down the formula into element names. And the second element, the anion, is always going to end with IDE. So let's do that for this one here. We're going to break down the formula into element names. We have K, that's potassium. And then nitrogen, when it's an anion, is nitride. Now the next step that we only have to do some of the time is to write down the anion charges. And let's go ahead and do that for the potassium nitride. The nitride, since it's in the nitrogen family, is a -3 charge. Now let's come back to the next step. You find the total negative charges. That's going to be negative. Find the total negative charges. And then if we have a transition metal, we have to figure out what the charge is on the transition metal. Now, with potassium, since that's an alkali metal, we know that that is always +1. So we have a +1 for that. Now, we've got 3 of them, since it's K3. So 3 times +1 cancels out a -3. These two cancel each other out. Now, what we're going to have to do on this one is we're going to break the formula down into the element names. So we've got tin, and we have fluoride. Remember, it ends with IDE because it's the anion. We're going to write down the anion charges. We have a -1 for fluoride. But we have 2 fluorides, so it's -1 and -1 equals a -2 if we add them together. So we found the total negative charges. What we need to do is cancel the negative charges. And I'm going to write negative, it's just a little negative sign with a circle around it. Charges. With cation charges to get the Roman numeral. So we're going to write cation as positive with positive charges to get the Roman numeral. So what we're doing is figuring out what the Roman numeral is for transition metals. So, SN, we only have one of those, so we only have 1 tin. So the charge on tin has got to be +2, so that a +2 cancels out the -2. So now we know that we're going to use parentheses in the middle here and put in a Roman numeral 2. So tin 2+ makes a neutral compound with 2 fluoride anions. Now let's try this one over here. We know that it is iron from Fe. Iron is not an alkali metal or an alkaline earth metal, and it's not one of our exceptions where we always know the charges, so we're going to have to figure out what the charge is. So we know we're going to need to use parentheses. And then oxygen we'll write down as oxide. We know we have 3 oxygens, so we have a 2 minus, 2 minus, 2 minus. So we have a total of -6 that we have to cancel out. And we've got 2 irons, so we're going to have 2 Fe, and we need to figure out what X is. So in order to cancel out a total charge of -6, we've got to have a +6 over here, which means X has to be +3. So this becomes a Roman numeral 3 up here. Ternary ionic compounds are very, very similar to the binary ionic compounds. Ternary means you have 3 or more different elements. And what it means is that you've got a polyatomic. So generally these compounds contain polyatomic ions. So ternary ionic compounds are 3 or more different elements, and the compounds generally contain polyatomic ions. And we're going to scroll down the page now and practice some naming with the polyatomic. Alright, so let's scroll on down here. Okay, let's take a look at what we've got here. We're going to treat them just like binaries, except use parentheses when there's more than one. So for an example here, we have magnesium hydroxide, and let's see how it works in terms of the charges. We have Mg 2+, and then we have 2 of the hydroxide anions. Now what I want you to do is box your polyatomics so that you remember not to tear them apart. You can think of them as a family that you're not going to separate. So what we have is magnesium 2+ is exactly canceled by 2 separate hydroxide ions. That's why we put these in the parentheses here, because we're showing that the OH stays together as the hydroxide ion. Let's look at the same thing here with ammonium sulfate, or excuse me, ammonium sulfide, NH4. Each one of those has a +1 charge. So we've got 2 of those. Sulfide, since it's in the oxygen family, has a 2- charge. So 2- is canceled out by 2 ammonium ions, each with a charge of +1. So let's try a couple here. You have potassium sulfate. So potassium is K1+. Sulfite is SO4. Box it so you remember not to mess around with that subscript. Leave that subscript alone. 2-. We're going to crisscross, just like we did with the binary compounds. So the 1 comes down, and the 2 comes down, and we get K2SO4. All right, put a little box around that so I know you're done and that's your final answer. Notice the SO4 stays together. Now let's try aluminum phosphate. Aluminum is Al, and you should have memorized the charge on that is 3+. Phosphate is PO4. Put a box around it because that's your polyatomic, and now write out the charge, and the charge is 3-. Again, you should memorize that. We're going to crisscross, so this 3 will come down here, this 3 will come down here. So we get Al3 PO4 3. Now I kept the phosphate in parentheses to show that the PO4s stay hooked together. So I have 3 of these PO4 units. However, there's a problem here. I always want to reduce the subscripts if I can. But you never touch the subscripts on a polyatomic, so you leave the 4 alone. You can touch things outside of parentheses, but not on the inside. So these 2 3s cancel. So our final answer is AlPO4. Okay, let's put a box around it so that I know you're all done. Okay, let's try manganese 4 carbonate. The 4 tells me that manganese has a +4 charge, so it's Mn4+. Carbonate, you need to have memorized, is CO3. Put a box around it so you remember that it's a polyatomic, and its charge is 2-. We're going to crisscross the 4 and the 2, so you get Mn2 CO3 4. But notice that these can be reduced. I can divide this and this by 2. So my final answer is Mn CO3 2. And I'm going to box it to show that that is my final answer. Okay, let's try formula to name practice. What we have here is Na2CrO4, so you're going to have to know your names of your polyatomics. Na is sodium. We know the charge on sodium is always +1. We do not need parentheses, so we can go straight to naming the polyatomic. And that polyatomic is chromate. So that was an easy one. Now we're going to get just a little more difficult. This next one, Sn, is tin. Tin is one of those ones where the charge or the oxidation state varies, so we're going to have to figure that out. So put in parentheses to remind yourself you need to figure that out. And then SO3, you need to memorize that one, is sulfite. Now you need to know the charge of sulfite, and the charge on it is -2. You only have one sulfite, you only have one tin, so your charge on tin also has to be +2. So it's tin 2 sulfite.